Hello, pre-calculus. Here are your composite inverse trigonometric function task cards from January 9th. This first one here, we want sine inverse of sine of 5/7. Now, the problems that we've talked about like this on your videos before and the ones in the book all gave you a nice happy little value or angle here that was in the sine inverse. And so the sine inverse kind of cancels out the sine and you would spit out a 5/7 over here. The problem though with this one is 5/7 is not in the domain of sine inverse, so we can't just spit out 5/7. So we need to graph this guy on a coordinate plane. Where would 5/7 be? Remember, this is 0 and this is pi, and we're talking about sevenths. This would be 7 over 7 pi, because then the sevens cancel out and we just have pi. And so halfway between here and 0 would be 3.5 pi over 7. Why do I care? Because I'm trying to figure out, is 5 pi over 7 in quadrant 1 or quadrant 2? Well, since 5 is bigger than 3.5, I know it's somewhere over here. So, like we said before, we can't just spit out 5/7 because that would mean 5/7 is in the domain of sine inverse. So instead, I just know that this is some point xy, and I need to find some other angle that has the same y value as 5/7, but that lives over here in quadrants 1 or 2, because that's where sine inverse is defined. Since y over here in quadrant 2 is positive, I need the y value to be positive. And my other place where my y values are positive are over here. And so just like when we were building our unit circle, and to find the point over here, we found our reference angle, right? We dropped it down to the x-axis. We found our reference angle. Remember, this was theta prime. We found this reference angle, and then we went over here to this reference angle. We got those points over here, and we applied them over here, and then we made the x negative. That's how we built that unit circle. Same thing applies here. So the angle that would have the same y value over here that's positive would be this angle here, which is the same as my reference angle, theta prime. So now I know I'm looking for my reference angle for this one. If this guy here is 5 pi over 7, how many more pi's over 7 does it take to get to 7 pi over 7? 2 pi over 7. So my reference angle is going to be 2 pi over 7, which means instead of spitting this 5 pi over 7 out, it's going to spit out 2 pi over 7. 2 pi over 7 is the same angle here, and it lives in quadrant 1, and quadrant 1 is inside the domain of sine inverse. All right, let's look at number 2. It's very much on the same line as number 1 with a slight twist to it. So again, 4 pi over 5, that half of 5 is 2.5, so 4 is past that, so I know it's over here in the second quadrant. Here's 4 pi over 5. Again, I'm going to find my reference angle. What is my reference angle? This is 4 pi over 5. It'd take another pi over 5 to get down to pi, right? So my reference angle is pi over 5. Well, on the last one, I said, okay, well, fine. Then I'm going to slap it over here into the first quadrant. We're going to call it pi over 5, and I'm done. But be careful. We're not talking about sine this time. So last time, we had an x and a y. Y is positive in the second quadrant. Y is positive in the first quadrant, so that's why we dropped it into the first quadrant. Fortunately, that's not going to work for tangent. We have to think even harder. So in tangent, my x and y values in quadrant 2, x is negative, y's are positive. If I have a positive over a negative, because remember tangent is y over x. In the second quadrant, y's are positive, x's are negative. Positive divided by negative means tangent is going to be some negative. So instead of taking my reference angle and putting it up here in the first quadrant where it's positive, I need to drop it down here into the second quadrant where it's negative. Instead of it being positive pi over 5, it's going to be negative pi over 5. And sign does matter. All right, that's 1 and 2. I'm going to try to keep these videos short. Just do 2 problems on each one. And then you don't have to swim through a whole bunch of video. Coming right up will be 3 and 4.